Hello, welcome to IT Expert YouTube video series. Today we are going to talk about 12 Factors app explained in 20 minutes. What is 12-factor app? The 12-factor app is a set of 12 principles or best practices for building web applications which nowadays are more commonly known as software as a service SaaS applications. It was published by the co-founder of Heroku, Mr. Adam Wiggins in 2011. These principles are the result of all the experiences and observations that the people working at Heroku, which is a platform as a service, have gained over a large variety of software as a service applications ever deployed on it. These principles help us to create the applications that use declarative programming for automation of setup, which in turn reduces the development time and cost of the projects when a new developer joins it, does not rely on any particular OS and are easily portable, are highly suitable for deployment on cloud and allows continuous deployment and are easily horizontally scalable without requiring many changes in the codebase. Why should we use the 12-factor app methodology? One of the most common reasons behind using the 12-factor microservice principles is that it can significantly enhance the app development process and bring costs down to a bare minimum. Here are a few other reasons why you should use this approach. The 12-factor app development principles help you create code that you can easily release, quickly scale, and consistently maintain. With 12-factor microservice principles, enterprises can create applications that use a declarative format for setup automation, thus minimizing time and cost for new developers joining the project. The 12-factor approach can help you create applications that you can quickly deploy on modern cloud platforms, removing the need for servers and system administration. With the 12-factor principles of microservices, you can create applications that you can quickly scale without any significant changes to the architecture, technology stack, or development practices. The 12 building blocks of 12-factor apps. 1. Codebase. Single codebase per application tracked in version control with many deploys. Let us break the official statement of it and try to understand the two main terms in it. In naive terms, a codebase is all the human-written source code that does not include the class or object files generated by the tools. A deploy refers to a single running instance of that particular application. Each application must have only a single codebase. Each such codebase must be managed in a version control system. Some popular VCS version control system includes Git, SVN and Mercurial. If there exists multiple codebases, then it's not an application, it's a distributed system. Each component of that system will be known as an application that shall follow the principles of the 12-factor apps. 2. Dependencies. Explicitly declare and isolate dependencies. We all must have observed this at least once in our programming career, that we have downloaded a Python library for some purpose and then found out that we have downloaded the wrong version of the library or have the wrong version of Python installed in our system. This generally happens because the task of managing the dependencies is given to the developer. Hence, this factor states that we must always declare the dependencies in the manifest file, a file containing the metadata for the dependencies like name, version. It increases the speed of the development as now the developer is free from the task of managing the correct version of the libraries. There is no need for explicitly downloading the required jars anymore. 3. Config. Store config in the environment. The source code and the configurations must be completely separated from each other. We must store all the configurations like DB credentials, path, URI and the environment variables as in general practice in the industry. Applications configurations vary from environment to environment like dev, test, prod, etc. Also, no configuration should be stored in Git in plain text. There is a very simple way in which you can check whether your current application follows this config principle or not by asking yourself that whether you can make your application open source right now without making any changes and without compromising any of your credentials. 4. Backing services. Treat backing services as attached resources. If we talk in very simple terms, then any service that your application consumes over the network is known as a backing service. Your application must treat these services as resources which it is consuming over the network. It gives us the advantage that our services become easily interchangeable and offer great portability to our application. A simple example is, suppose your application is currently using a local PostgreSQL database for its operations and it is afterward replaced with the one hosted on the server of your company by just changing the URL and the database credentials. 5. Build, release, and run. Strictly separate built and run stages. The deployment of your application must be properly separated into 3 non-overlapping non-dependent phases, namely build, release and run. The build phase constitutes the compilation of the code which in the end generates the artifact like a jar or WAR file. The second phase, release, take the artifact file generated at the end of the previous phase and adds the configurations for a particular environment to it. The last phase includes the running of the instance of the application. 6. Processes. Execute the application as one or more stateless processes. An application is said to follow this principle if its instances can be created and destroyed any time without making any effect on the overall functionality of our application. To achieve and fulfill this principle, our application must store any type of data generated by it in any persistent stateful data store. But it does not mean that we not use the in-memory of the processes of our application. We can use it to store as temporary storage. In simple terms, the usage of sticky sessions must be avoided. Sticky sessions, in simple terms, refers to catching the logged-in user's session data in the local memory of the process and then directing each subsequent request from that particular user to the same process. The problem with sticky sessions is that it causes uneven load balancing among the instances of the application. 7. Port binding. Export services via port binding. Any application that follows this principle is completely self-contained and standalone. It exports HTTP as a service and does not require any server like a Tomcat to listen to requests. It binds itself to some particular port and listens to all the requests hitting on that port. You must also have observed it while designing an application or a microservice which runs on a particular port and you hit requests on that particular port using Postman to get a response. This information that to which port our service will be listening to is also stored in the configuration file itself. 8. Concurrency. Scale out via the process model. An application that follows this principle must be divided into smaller different processes instead of a single large application. Each such process must be able to start, terminate and replicate itself independently and at any time. This principle allows scaling our application very easily. By scaling out we refer to horizontal scaling in which we run multiple instances of our processes. It adds concurrency to our application in a very simpler way due to the existence of independent horizontally scalable processes. 9. Disposability. Maximize robustness with fast startup and graceful shutdown. Robustness of an application refers to the graceful starting and termination of its processes without affecting the overall application's functionality. For example, one of the processes of our application is storing the details of a newly added employee to the company and to a database. But while doing so, in between an unexpected error occurs which causes the process to terminate in between unexpectedly. However, the state of our application or database must not be affected by it and the process must fail safe. Also, it must start quickly whenever required. 10. Development production parity. Keep development, staging, and production as similar as possible. It simply means that the development and production environment must be as similar as possible. The processes being used, technologies and the infrastructure must be the same. This will help you in a way that whatever error that can happen over time will happen at the development stage itself instead of surprisingly occurring in the production. This helps in the continuous deployment of our application and reduces the development time and efforts also. 11. Logs. Treat logs as event streams. Logs are very essential to understand the internal working of the application, and it can be of different levels and are generally stored in a file named log file in the storage. Ideally, our 12-factor application must not be worried about the storage of the logs. Whenever a request enters into the system, corresponding logs are made and they are treated as a sequence of events that can be used to debug when some problem occurs. 12. Admin processes. Run admin management tasks as one-off processes. Most of the applications require a few one-off tasks to be executed before the actual flow of the application starts. These tasks are not required very often and hence, we generally create a script for it which we run from some other environment. On the other hand, the 12-factor methodology says that such scripts must be made a part of our codebase itself managed in the version control system. These tasks should also follow 12-factor principles. Who uses 12-factor app methodology? The 12-factor methodology is a rule book for building SaaS applications, and several leading companies like Amazon, Heroku, and Microsoft follow its listed principles. Some widely used frameworks like Magento and Spring Boot also credit 12 factors as a part of their design. These principles help design and maintain a robust and modern app architecture for cloud-based apps, ensuring the timely release of new features and fixes. Software developers working on software as a service solutions, cloud applications, distributed software solutions, microservices. Follow the 12-factor app methodology principles to ensure maximum automation and agility by minimizing divergence between development and deployment. 9 Rules guiding the 12-factor app. PMI-ACP offers the 4 words that 12-factor stands on. Performance. For 12-factor apps, you are scaling out for a lot of copies of the code, meaning performance must be a priority. Elasticity. Focus on scalable components that can grow and shrink as needed. PMI-ACP recommends Chaos Monkey as a tool of not only bad data but scaling up. Resilience. You want to loosely couple your pieces. By each component doing only one thing, uptime increases. Security. All data should be encrypted whenever possible, building security into design. If it's a known fact that 80% of attacks are internal, PMI-ACP says it's not that they can't get to the network, they are already on the network, which means you must ask the security questions before someone else asks them and it's too late. Ask the security questions yourself before someone else asks them when it's almost too late. And then you need to follow these 5 design principles, most of which are so logical, it'd be good if they are followed for all cloud-based services. Interview question and answer. 1. What does microservices mean? Explain the term microservices. Answer. Microservices is a systems development lifecycle (SDLC) approach in which huge applications are built as a collection of small functional modules. These modules are deployed independently. They are scalable and can communicate with each other over standard protocols. 2. What are the advantages of using microservices? Answer. If you have been doing software development, then you know that microservices is the future. The biggest advantage of microservices is that it fits nicely in cloud infrastructure. By using containers like Docker, it's easy to deploy and scale, and it also makes the development easier. Here are some key advantages of using microservice architecture. They can be deployed independently. They are fault isolated. They are technologically diverse. Deployment time is less. 3. Name the main components of microservices. Answer. Containers, cloud infrastructure, API gateway, service delivery, IAC, and service bus. 4. How is microservice architecture different from monolithic architecture? Answer. Monolithic architecture is tightly coupled mostly, while microservice architecture is loosely coupled. Microservices focus on products while monolithic architecture focuses on the whole project. Moreover, service startups are faster in the microservice architecture. If you want to learn more about microservice architecture, I highly recommend the An Introduction to Microservice Principles and Concepts course on Educative. This is a text-based interactive course that allows you to run code on a browser. 5. What is the meaning of RESTful? Answer. RESTful means Representational State Transfer Web Services. It's based on HTTP protocol and has been the backbone of modern web development, which is highly based upon APIs. 6. What is the meaning of OAuth? And why is it used? Answer. OAuth means Open Authorization Protocol. OAuth is used to access the client applications on HTTP for third-party providers Facebook, GitHub, etc. on Java World. Spring Security supports OAuth 2.0, which you can use to secure your application. If you want to learn more about OAuth and Spring Security, I suggest you join OAuth 2.0 in the Spring Boot Applications course on Udemy. It's a great course to learn OAuth 2 in depth. 7. What are some challenges faced while using microservices? Answer. Here are some challenges faced on building applications on microservices architecture. Being a distributed system, microservice architecture is a heavily involved model. Microservices always need to communicate with each other because they always rely on each other. There are always operation overheads. 8. What is the use of containers in microservices? Answer. Containers are used to manage microservice-based applications. They are easy and effective. Containers also help effectively in deploying and developing individually. The biggest advantages of containers are that they are easy to scale. You can easily scale your microservices using tools like Kubernetes, which can manage containers at scale. Containers also make deployment uniform. For example, you can deploy a microservice written in Java or any other programming language in the same way. 9. Explain end-to-end microservices testing. Answer. End-to-end microservices testing is a technique in which the entire flow of the application is tested using a business transaction. Such kind of testing covers the gaps left during other testing techniques such as unit and integration testing. 10. In what kind of application we should use microservices? Answer. Microservices should be used in applications like web, desktop, mobile devices, smart TVs, etc. Thank you for watching this video. We provide hands-on training with labs, homework, group projects. Prepare you for the certification. Provide real projects. Internship opportunities. Support you and resume LinkedIn. Staffing support. Provide tech references. In-person online class. Class retake options and more. Call us at 847-350-9034 for your free career consultation meeting. Please do not forget to like, share, and subscribe to our channel for the latest videos.